Okay, so this is question 7, and I think this was in the 2019 paper. So again, this is one of the function questions. So if we have a read over the question, a camogie golf player on a level pitch hit a ball straight up into the air. The path that the ball travelled can be modelled by this function. So this is our function here. Now, instead of using x and y, they're using t and m for height, so time and height. So function t is equal to minus 4 times t squared plus 16t plus 1. Now straight away we can see, if we look at this, so we can see it's a quadratic because you have t to the power of 2, and it has a negative sign in front of it. So when we fill out this table and we plot these points, we would expect to get a graph that would look something like this. So where t is the time in seconds from when the ball is hit, and ft is the height the ball travels in meters above the pitch. The ball landed on the ground without being hit again. Okay, so the ball is basically, so at t0 it's going to go like this. It's going to take this kind of an arc. So the first question they ask you to do is, at what height was the ball when it was hit by the goalkeeper? So this is going to be time 0. Okay, so at what height was the ball? Well, it's going to be when this function, so function 0, and you have to work that out. So let's have a look at that and see how that works out. So we would write, so at time 0, that will tell us that's like the height the ball was at when it was hit by the goalkeeper. So we just write it out like this. So it's going to be function 0 is equal to, and again just mind the signs, is equal to minus 4 times 0 to be squared. Okay, so we're just taking this function and we're taking this value for t plus 16 times 0 plus 1. Okay, so make sure and write this out like this because you're going to get marks just for doing this. So therefore function 0 is going to be equal to, so this whole term here is just going to be 0 was 0 was 0, and then 4 zeros is just 0. 16 times 0 is 0, and then you're just going to be left with 1. And if we have a look here at the question, so it tells us that t, so this t here, so t for example is what goes in here, so that's equal to time. And then this whole thing, function t, that's equal to, let's say, height. Height, let me just move this down a bit. So height in meters. So what we can say is that the ball at time 0 was 1 meter. Okay, so f0 is equal to 1 meter. So that would be the answer to the first one. So function 0 is equal to 1 meter. Now, it's important that you show this calculation, this workout, and not just write in this. You want to show how you've actually worked it out. Okay, so then the next part then is what we need to do is we need to fill out this table. So complete the table below to show the height of the ball at various intervals during the first 4 seconds of its flight. So we can use this, so this is A, and we want to move on now to part B, so B. So we've worked out the first one, so when t is 0, the height is 1 meter. So now what we want to do is we want to work out all of these. So we use this function here, and we just substitute in our value for t. Okay, so the first one is 0.5, so you're talking about function 0.5 is equal to minus 4 times 0.5 to be squared plus 16 times 0.5 plus 1. So then if we work this out, so 0.5 squared, so that's 0.5 multiplied by 0.5, that's going to be a quarter. And then a quarter multiplied by minus 4, that's going to be, so that's going to be equal to minus 1. So this here will be equal to minus 1 plus 16 times 0.5, so 16 multiplied by 0.5, that's going to be equal to 8 plus 1. And if we add these up, so this minus 1 will cancel this out, and we'll be just left with 8. So we can say that function 0.5 is equal to 8. So that's that one there. Then we want to do this one. So function 1, that's going to be equal to minus 4 times 1 to be squared plus 16 times 1 plus 1. So this will just be equal to minus 4. This is plus 16 and then plus 1. So let's say, so this will be minus 4 plus 17. So that's going to be equal to plus 13. So function 1 is going to be equal to 13. Let me just double check that. Yeah, it's going to be 13. Okay, so that's that one. Then you want to do this one here, function 1.5. Function 1.5. So that's equal to minus 4 times 1.5 to be squared plus 16 times 1.5 plus 1. So 1.5 multiplied by 1.5. So that's equal to 2.25, and then 2.25 multiplied by minus 4. That's going to be equal to minus 9. That's minus 9 plus 16 times 1.5. 16 multiplied by 1.5 is equal to 24 plus 24 plus 1. So then 24 plus 1 is 25 minus 9. So 25 minus 9 is equal to 16. So therefore function 1.5 is going to be equal to 16. So that's 16. The next one then is function 2. I'm just going to move down a bit here so we can see what we're doing. I might just move up here. So then the next one then is function 2. So function 2, so that's going to be equal to minus 4 times 2 to be squared. So again, I'm just taking this from here. Plus 16 times 2 plus 1. So 2 by 2 is 4, and minus 4 by that's going to give you minus 16 plus 32 plus 1. And so 33 minus 16, so 33 minus 16 is going to be equal to 17. So we can say that function 2 is equal to 17. Okay, so that's that one there. So 16, just double check this one now. That's 33 minus 16 is 17, yeah. So that's 2.5 is 16, Then this one here is a function 3. And I'll just start writing them in here. It's a function 3 then. So function 3, so this is from here, is going to be equal to minus 4 times 3 to be squared. Minus 4 times 3 to be squared plus 16 times 3 plus 1. Okay, so that's 3 by 3 is 9. 4 nines, 4 multiplied by 9 is equal to 36. That's going to be minus 36. So minus 36 plus, so 16 and 16 by 3 equal to 48 plus 48 plus 1. So 48 and 1 is 49. So 48 plus 1, that's equal to 49, and then minus 36. 49 minus 36 is equal to 13. So this function 3 then, function 3 is equal to 13. So that goes in there. So then we want to do function 3.5. Is equal to minus 4 times 3.5 to be squared plus 16 times 3.5 plus 1. So that's 3.5 by 3.5, 3.5 multiplied by 12.25 multiplied by 4. So that's equal to minus 49 plus 16 times 3.5. 16 multiplied by 3.5. That's equal to 56 plus 1. So 57 minus 49. So 57 minus 49. That's going to be equal to 8. So function 3.5 is equal to 8. So that's that one there. And then the last one then, function 4. So function 4, that's going to be equal to minus 4 times 4 to be squared plus 16 times 4 plus 1. So 4 by 4 fours, 4 fours is 16. So 4 multiplied by 16 then is 64. That's going to be minus 64. 16 and 16 is 32, 64 plus 64 plus 1. So these will cancel out, that will cancel out with that, and you'll just be left with plus 1. So function 4 is equal to 1. And that's that one there. So you can see here, so it starts at 1, goes to 8, 13, 16, 17, so it kind of levels off. So it's going to be your peak at 17, and then it starts to drop 16, 13, 8, 1. Okay, so you can see that there's a pattern there. So this is the first part of this question. So again, you're going to get a lot of your marks for doing this workout, so just make sure and show all the workings out of your question, and fill in the table here. So complete the table below and show the height of the ball at various intervals. Okay, so that's what we've done there. So the next part then is on the graph below, show the height of the ball while it was in the air. Okay, so what we want to do now is we want to take these measurements here and we want to plot them on this graph. So what I'm going to do is I'm just going to move this up here. Let's move it up to one side here. Okay, move this up here so we can actually see it a bit better. So what we want to do now is we want to plot these points here. So notice that this axis here is for time, okay, and then this axis here is for height. So we have time are these guys here, and height are these guys here. So let's plot each of these, okay? So the first one is time is 0 and height is 1. So at 0, the height is 1. So it's going to be about here. Okay, so that's the first point. That's this point here. The next one at 0.5. So 0.5 is here. The height is at 8. So it's up about here. Okay, so that's the second point. So we can just tick these off as we move across. The next one is at 1 second, which is here. The height is at 13. Okay, so the height is about here. So that's that one. At 1.5 seconds, the height is 16, so 1.5 is here. The height is going to be up about here. So that's 1.5. At 2 seconds, the height is at 17. So 2 seconds, the height is up here at 17. And this looks like the maximum height. And then it starts to fall. So at 2.5, which is here, the height is down to 16, which is about there. The next one then is at 3, the height is at 13, so at 3 the height is at 13, which is going to be about here. So 3 seconds. And then 3.5 the height is at 8, so 3.5 the height is at 8, which will be about there. And then at 4 seconds the height is at 1, so 4 seconds the height is back down here at 1. Okay, so that's the trajectory, and that's the kind of shape that we would expect as well, given the function that we were dealing with at the start. If we have a look at the function here, so this function, so again it's a quadratic function, and this shape is a quadratic shape as well. Okay, so what we want to do now is just join up the points. So again, I'm just going to do it rough here, but just use your ruler when you're doing it. So you want to plot these points like so. So you can see we're getting that characteristic shape of a quadratic function. And it comes back down to about there. And notice as well that down here, like so this kind of trajectory here is just past 4. Okay, so the time when it hits the ground is just after 4 seconds, 4.1 seconds. So what it's asking you then is the length of time the ball was in the air from the time it was hit until it landed on the ground. Okay, so at time 0, which was here, okay, so between here and here, that's going to be the time that it was in the air, if you like. So that's it between here. So if you like, so from here right up to here, that's going to be the time that it was in the air. So then if we count that in seconds, so this is 0. So we've 1, 2, 3, 4, and it's just about 4.1. So it's about 4.1 seconds. And again, if you just show this on you can highlight this on the graph as well. So you can just put like a dot here like that. So that's the time. So the length of time the ball is in the air when it landed. Okay. So the next one then is the length of time the ball was 10 meters or more above the ground. So again, this is where you can take your ruler. And where was it? So if we go up here to 10, so roughly here. So we can see here that between here and here, so between this point here and here, okay, so you could even just draw a line across like this on either side. I'll just get rid of that now. So what we can see then is if we draw a line down here, we can draw a line down here. And then we can, so at this point here, draw a line back down here. So you can see that between these 2 points here, so between this time and this time, we can see that the height was above. So here, all here, it's the height. The height is greater than 10 meters. So we want to try and figure out how much time that is. So if we take, so let's say, so this is, so it's roughly that there is about, so that's 0.5, so it's roughly about 0.6, and then here it's about 3.14, I'd say, 14. Okay, so that's that time there, and this time here. Sorry, not 3.14, 3.4, should I say? So that be, so it's about 3.4. So that's 3.4. So then we want to work out like what's the time between those two. So it's going to be, let's say we want to find out what's this time from here to here. So it's going to be 3.4 minus 0.6. If we use our calculator, so 3.4 minus 0.6, that's equal to 2.8. So it's roughly 2.8, so 2.8 seconds. So the length of time the ball was 10 meters or more above the ground was about 2.8 seconds. Okay, so that's that question in full. So again, what's really important here is that you show all the workings out for completing this table, then you plot your points on the graph, and then you answer the questions based on the graph as well. So hopefully that makes sense, and that's helpful.